All right, now that we have talked about how to do a linear model and talked a little bit about how the residuals show us how well the linear model fits the data, we are going to now take a look at something called a correlation coefficient, which is essentially a way of kind of summarizing all of the residuals into one number that tells you how good the line fits the data. All right, so we're going to be focusing on that term today called the correlation coefficient. All right, so we're going to start off with a little bit of a kind of a warm-up problem here, and it is simply which one doesn't belong. Now there's more than one answer that you might give to this, so maybe at this point you can just kind of pause the video and decide which one you think doesn't belong and maybe write a little bit about that. And then I'll talk through kind of one of my reasons that I chose the one that I chose. So go ahead and pause for just a moment. So the one that I chose for the one that didn't belong was B. I'm guessing some of you guys also may have chosen B, but you might have chosen one of the other ones, and if you gave some reasoning related to that, that could certainly apply. I chose B because B is the only one that I saw here without a pattern, without a predictable pattern. Now, I think there are a couple of these that are pretty predictable and are predictable in a linear sort of way. So A definitely seems to be a linear relationship when we look at the pattern between the distance in miles and cost in dollars. I'm guessing maybe that's a gas sort of problem there. And in C, we kind of have the reverse trend, where as the precipitation goes up, the water used for irrigation goes down. So how much extra water that you need to use for the irrigation. Irrigation is essentially how crops are watered and on farms, but also in our yards. Sometimes people put in irrigation systems. Sprinkling systems are sometimes called irrigation systems for making your lawn green. And then there's this one in D, which is definitely not a linear relationship. Like C was probably a linear relationship just like A was. But this one sort of has a pattern, right? And it's not a linear pattern, but it seems to have a pattern such that the points would continue to go in this direction. And so if we're looking at a model, and there are different types of models you can use. You don't have to just use a linear model. You can use exponential models, which we might get a chance to talk about. There's something called quadratic models that have an equation that kind of looks like that. Exponential can look like that or like that. So there's different sorts of models that are not lines, but are patterns that we can model with. And so D seems to have that sort of non-linear, maybe an exponential sort of situation with temperatures. As the temperature increases, the number of phytoplankton, phytoplankton, which is I think a little animal, isn't it? Plankton is what whales eat. It's like I want to say a plant, but I think it's a little animal that are in the water. I'll have to look that one up again, remind myself. In any case, B is the one that you kind of have no real connection, no real pattern. So height versus weight in that case, we didn't really have a predictable pattern. So that's what I chose. And maybe you chose that one or something else.